Hello there, Mr. Pagan at the helm, and today we're going to talk about reflections. Now, before we get into it, I want to do a quick algebra review, and it says to graph the lines x equals 2 and y equals negative 4. Now, x equals 2. If you recall, x equals is always a vertical line. Alright, now, it's a vertical line for this reason. So x equals 2, well, x equals 2 right here, and the graph reflects that here. Now, if you think about this, where does x equal 2? Well, anywhere on this line. Here, x is 2, 1, 2, 2, 2, 3, 2, 4. So that's why it's a vertical, because anywhere on this line, x is 2, 2, negative 4. Alright, now, easy way to remember this is I always remember if you cut an x in half, it makes two v's. V is for vertical. Alright, and then we have y equals negative 4. Now, y equals are horizontal lines. Alright, for the same reason. So y is negative 4 right here. And it's a horizontal line, so horizontal side to side. And again, if you think about it, everywhere on this line, x equals negative 4. Here's negative 4, 3. Negative 4, negative 3. Negative 4, 9, so on and so forth. And how I remember this is if you flip a y upside down, kind of resembles an h. Again, that's just a little trick to help you remember it. But mathematically, the correct reason is because y equals negative 4 anywhere on this line. Alright, now that we recall this, we can go ahead and move forward. So a reflection, a vampire has no reflection. Now, a reflection is simply a mirror image. Okay, a reflection is a mirror image of yourself. And think about it, when you look in the mirror, you see yourself, it's just a reflection. You're kind of flip-flopped, right? So what we're going to do is we're going to reflect about some lines here. And this is a pretty involved problem here. And we're going to do it all on one grid. So follow along closely. And we're going to start by giving the points A, B, C. So let's plot those points. A is negative 6, 8. Call that point A. B is negative 2, 7. Call that point B. And C is negative 4, 2. Call that point C. Now let's connect these dots to form a triangle just to kind of give us a sense of the shape we're reflecting. It's not a good line. So there's my triangle. Now, the first one says reflect about the line x equals 0 and name the coordinates. Now, we set up above x equals is a vertical line and x equals 0. Well, where's x 0? Right here in the middle, right? So x equals 0 is really just my y-axis. My x equals 0 line is this right here. Alright, so we're reflecting about that line. Now I'm going to erase it just so it's a little neater and we can see, but I wanted to show you where that line was coming from. Now we reflect about a line, so we're reflecting the image that way, across this line we said. Okay, so when we do that, you simply count the amount of spaces and the direction you're going. So we're moving to the right because we're reflecting about that line. So let's start with point A. I'm 1, 2, 3, 4, 5, 6 units away from my line. So I'm going to go 6 units in the other direction away from my line. 1, 2, 3, 4, 5, 6. And I'm going to call this A prime. Now here I'm going to go 1, 2 units. So I go 1, 2 units. And I'm going to call this B prime. And then C is 1, 2, 3, 4 units. So I'm going to go 1, 2, 3, 4 units and call that C prime. And there's my triangle there. Now, if you think about it, and you really look at that, it's exactly what happened. B flipped here, and then this whole segment here kind of flipped around there and went to that side. Alright, so all we did was reflected about that line, the entire image. And it wants us to name our new coordinates. So we're going to say A prime is 6, 8. B prime is 2, 7. And C prime is 4, 2. Now, if you look back at our original coordinates, you can kind of see a relationship, right? Well, that's because we kept it on the same horizontal line. The only difference is we flipped it to a new quadrant. So in that quadrant, everything's positive, as in this quadrant, we had negatives and positives. All right, so part B says, now reflect about the line y equals 0. Well, we know y equals 0 is a horizontal line, and y is 0 right here. So that's going to be my line. So now we're reflecting down. Alright, so let's do that. Let's just start with A again. We are 8 units away, so we're going to go 8 units away. And we're going to call that a double prime because we've now switched the original point twice. And then we're going to take B, we're 7 units away, so we're going to go 7 units away and call that B double prime. And C, we're simply 2 units away, so we're going to go 2 units away and call it C double prime and draw my line. Again, as you begin to visualize it, you can see the reflection. Okay, and then lastly, part C says we're going to reflect about the line x equals -2. Let's make this one green. So x is a vertical line about -2. So my line's going to be right here at -2. And again, we simply count the distance. Now we're going right to left. 1, 2, 3, 4, 5, 6, 7, 8. So we go 8 in this direction, and that gives me A triple prime. And then B, we're going 1, 2. So we're going to, 1, 2, 3, 4 all the way the line. So we're 1, 2, 3, 4, B triple prime. And then C, we'll go 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Typically, we won't go triple prime. I would change the name of the coordinates from like A, B, C to D, E, F. But for the sake of this exercise, we'll just keep it as is. Alright, so that's reflecting about a line. Now, tomorrow at class, I'm going to ask you one question. I'm going to say, does reflection preserve congruency? And I want you to tell me yes or no. Do these triangles preserve the same shape as they go through it all? And then the second thing is I'm going to ask you, do they preserve orientation? Does their uprightness or the way they rotate, is that held constant throughout this? And I'm going to ask those two questions. So I want you to think about those tonight. And let me know tomorrow. But we got one more thing real quick. So we want to, given the point 8, -1, reflect about the line y equals x. Now this one's a little trickier because let's plot the point 8, -1. So it's right here. And we have this point. Now, the line y equals x is actually a y-intercept of 0, and then our slope is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it looks something like this. Alright, so your y equals x line mathematically looks like this. Alright, it's kind of like a diagonal line that cuts my coordinate plane in half. Now, to reflect about it is kind of tricky to guess and to see. So we actually use what we know about algebra. Now this is saying make y equal x and make x equal y. Well, if we simply make this is x, this is y, we're going to make y equal x. So now x is going to be -1, and we're going to make x equals y. So now y is going to be 8. So all we simply do is flip the coordinates. And now we're going to plot this point, -1, 8. And when you visualize it like that, you can kind of see how the distances here are reflected, and they're pretty close. Now, if we would have to guess and count, it can get a little tricky. So we just use what we know about the expression that was given to us, and we flip them. So let's say I wanted to take -2, 3, and reflect it about the line y equals x. Again, I would simply take my coordinates and flip them. So 3, -2. Lastly, what if I want to do 401 and -4? Again, y equals x and x equals y, so we take -4 and 401. Alright, well that's all I got for today. Have a good one.